All right, so these are the notes for the zero product property in terms of solving. So right here, we're going to go and read what it says. It says zero product property, if the product of two real numbers is zero, then at least one of the numbers is zero. So what does that mean algebraically? If A and B are real numbers and AB equals zero, then you set each factor equal to zero and solve. So then A equals zero, B equals zero, solve for A and solve for B. So let me kind of show you what this looks like when we're dealing with algebra here. So for the first problem, number one, before you attempt to do it, make sure that it is set equal to zero, because once it's set equal to zero, it is ready to solve. So in this case, we have this, and it's set equal to zero. There are no common factors because it's already factored. So this is my first factor term, 5a, so I'm going to take that and set it equal to zero. And my second factor is a minus 12. We'll take that and set it equal to zero. And now all we have to do is isolate the variable to solve. So for the first one, this is 5 times a, and we undo this by dividing both sides by 5. And we come up with a is equal to 0 for the first one, and that's my first solution. For the second one, a minus 12 equals 0, we add 12 to both sides. And we come up with that a is equal to 12. For number 2, once again, it is set equal to 0, and it's completely factored already. So we take each of our factors and set it equal to 0. So for the first one, c minus 2 equals 0, we're going to add 2 to both sides. And c equals 2. And for the second one, we subtract 1 from both sides. And c equals negative 1. And you can always plug these back in, and you'll verify that it does equal 0. Like 2 minus 2 is 0. 2 plus 1 is 3, but 0 times 3 is 0. So the answers will check out. All right, let's take a look at 3 and 4. Same thing. All right, for this one here, we have set equal to 0 again, and it's factored again. So for the first one, we're going to say 2b minus 6 is equal to 0. 3b plus 18 is equal to 0. So for the first one, to solve for b, I'm going to add 6 to both sides. So 2b equals 6. Then I'm going to divide both sides by 2 to isolate the b, and b is going to be equal to 3. For the next one, 3b plus 18 is equal to 0, so we're going to subtract 18 from both sides. So 3b is equal to negative 18. To isolate b, we just divide both sides by 3. And in this case, b equals negative 6. All right, and now for this last one here. Now, this last one, once again, it is set equal to 0, so it's ready to solve. So let's talk about this square right here. What the square pretty much means is that there's 2w plus 4s. So I don't need to set w plus 4 and w plus 4 both equal to 0. I just need to take one of them and set it equal to 0, because the answer is going to be the same. And the w plus 1 I will also set equal to 0. So from here, we solve this one by subtracting by 4. So w equals minus 4 or negative 4. For the second one, we subtract 1 from both sides, and we come up with w is equal to negative 1. All right, now let's take a look at examples where we actually have to factor first and then solve. So if you paid attention in the previous video, you would know that to factor using the greatest common factor, you're first going to look at the coefficients, and then you're going to look at the variables and see what they have in common. So for the first one here, I see this one has a coefficient of 6, and this one does not have a coefficient, so we assume the coefficient is 1. So 6 and 1 do not have a common factor other than 1, so we don't use that. When we look at k squared and k, we see they both have a k. And to find the common factor, we pick the one with the smallest power, because that will fit into either k squared or k. So in this case, k squared and k to the first is smaller, so that's what we use. Now next, we have to figure out k times what is 6k squared. So hopefully you thought it was 6k, because 6k times k is 6k squared. K times what is 1k, which is just going to be 1. Okay, now we can see it's factored and set equal to 0. So what we're going to do is we're going to set each factor equal to 0 now. And now we're going to solve it. Now, if you take a look, the first one, k equals 0, is solved. There is no addition or subtraction or division that we need to take care of. But for the second one, 6k plus 1 equals 0, so we're going to subtract 1 from both sides. So we get that 6k is equal to negative 1. And then here we're going to divide both sides by 6. K equals to negative 1/6. And then for our last problem here, we have 6x squared equals negative 72x. So this time we'll notice that it does not equal to 0. So what we need to do is bring everything to one side. So I'm going to add 72x to the same side as 6x squared. Now notice I cannot add these two together because they're unlike terms. X squared and x are not the same. So we have 6x squared plus 72x, which is equal to 0. Now from here, 6 and 72 are both divisible by 6. And we have x and x. The one with the smaller power is x to the first, so that's why I have 6x as my greatest common factor. 6x times what is 6x squared? That is x. Okay. 6 times what is 72? That is 12. And we don't need the x because x is already there. So if you were to distribute this out, 6x times x is 6x squared. 6x times 12 is 72x. And now it's set equal to 0 and is ready to solve. So we're going to set each factor. So 6x is one factor and x plus 12 is the other factor. And we set each one equal to 0. So how do I know what a factor is? A factor that I set equal to 0 must have the variable in it. So these both have a variable of x. Okay. So to solve these, the first one, 6x equals 0, divide both sides by 6. And we get that x is equal to 0. For the second one, x plus 12 equals 0, we subtract 12. And x is equal to negative 12. All right, so those are our answers there. And now we're just going to take a look at a word problem real quick and see how that applies. So it says a boy kicks a ball in the air. The height y in feet above the ground of the ball is modeled by this equation. Y equals negative 16x squared plus 80x, where x is the time in seconds since the ball was kicked. Find the roots of the equation when y equals 0. Explain what the roots mean in this situation. Okay, so pretty much I could say negative 16x squared plus 80x is equal to 0 because it says y is 0. So we're changing that to 0. From here, I'm going to find the greatest common factor. So negative 16 and 80. Let's take a look here. So let me see if it does fit in. So 80 divided by 16. And 80 divided by 16 is 5. And I'm going to factor out this negative because I like to keep the square term positive. So I'm going to factor out negative 16. And they both have x. And the one with the smaller power is the 1, not the 2. So negative 16x times x is negative 16x squared. And a negative times a negative is positive. And then 16 times 5 is 80. And we already have the x here. So negative 16x times 5 is negative 80x. And then we set that equal to 0. Now that we have it factored completely and set equal to 0, we set each one individual factor equal to 0 and we solve. Okay. So for the first one, to solve this, we just divide by negative 16. And we get that x is equal to 0. And for my second one, I add 5. And x is equal to 5. So these are my two roots. It says to find the roots of the equation when y equals 0. Explain what the roots mean. Well, the first root is where it's launched from, right? It says the height y in feet above the ground of the ball is modeled by this equation. So a boy kicks a ball in the air. So they actually start kicking this ball from 0 feet. And this is 0 feet, 0 seconds. And then it takes 5 seconds for the ball to reach the ground again. So it's a parabola facing down. So it starts at 0 seconds and it takes 5 seconds for the ball to come back and hit the ground.